All right, linear inequalities in two variables. We solved inequalities in an earlier lesson, I think lesson 1, where we graphed on a number line. Okay? In this case, we're going to look at them with two variables where we have y is greater than some form of x, and we're going to look at the graphs of them. The actual line for that is called the boundary line. So here we talk about what's called a boundary line. And you can see that boundary line right here, that what it does is it separates the graph into two separate planes or two separate areas. The part that's above the graph is going to be above the line, is what we call where it's going to be greater than the equation for the line. And the part below is where it's going to be less than. And that's always the case. If, however you draw the line, if the area above it is always where it's going to be greater, the area below it's where always going to be less than. But we're actually going to check some points, or at least one point, to make sure that it's true. Okay. Right. So here we've got two lines. We're looking at both of these, and we're going to graph them. Okay. First one says y is greater than negative 1/3 x plus 2. Now, just like with when you do on a number line, if I have greater than or less than, we put an open dot, right? Yeah. When we're talking about a boundary line then, okay, like here, if we're talking about greater than or less than, we're going to use a dotted line. Okay? And if we're talking about if it has greater than or equal to or less than or equal to, then it's going to be a solid line. So the thing is, in this case here, it's going to be a dotted line because we just have greater than. So we'll graph that line. So we've got our y-intercept is at 2, and our slope is negative 1/3. And so that means that we're going to go down 1 over 3, put our dot there, and then we'll graph a dotted line through those points. Now, to determine where to shade, what's the easiest point to use? 0, 0, okay, the origin. So if I put 0, 0 in, so if I put 0 in for y and 0 in for x, it needs to be a true statement. So we're checking this point right here to see if it's true for this point. If it's true, we'll shade below the line. If it's false, then we'll shade on the other side of the line, or above the line in this case. And I already know because it says greater than, it's going to be above the line, but we're going to check it. So is 0 greater than, and when I multiply these together, I get 0, 2. Is 0 greater than 2? No, it's false. So that means that I'm going to shade the other side of the line, so my answer is going to be up here. And please don't use the rulers for helicopters. They're not helicopters, all right? So don't put them on your pencils. They're used for drawing straight lines or measuring. Letter B, y is less than or equal to negative 1. Is this a horizontal or vertical line, first of all? It's going to be a horizontal. Since there's no x there and it's a y equals a horizontal line, so I'm going to draw a horizontal line at negative 1. And since it has less than or equal to, that means it's going to be solid line too. So if I put 0 in here for y, would that be a true statement? Is 0 less than or equal to negative 1? Is 0 less than or equal to negative 1? Is 0, is that number less than or equal to negative 1? No, it's greater than, right? Okay, so then we're going to shade It's false, so we'll shade below the line. So basically all this is we're looking at graphing lines, determining whether it's going to be dotted or solid, and then determining whether we're going to shade above the line or below the line. Okay, using intercepts to draw the lines, to do the graphs, and then to do the shading. So if it's not in slope-intercept form, then you can use intercepts if you want. And then, here's that helpful hint I already gave you. Okay, the easiest point to test is 0, 0. Okay, so we're going to find the intercepts here. So we'll let x equal 0 to find the y-intercept. And when you're doing this, just use equals. You don't need to have the less than or equal to. We only need to be concerned with that when we draw the line and which side we shade on. So then y is going to be equal to 3. So then we'll put 0 in for y. To find the x-intercept. So then x will be equal to 4. So when we graph these, we graph the y-intercept, so that's at 3. The x-intercept's at 4. And tell me if I'm going too fast. Am I going too fast? Okay, all right. Okay. So find the x-intercept, or the y-intercept, put 0 in for x. Find the x-intercept, put 0 in for y. All right, and then draw our line. Is it going to be a dotted or a solid line? Okay, it's got the line under the inequality, which tells you it's going to be a solid line. And make sure you have your arrows. And then this is a situation where it's really important that you check by using the point 0, 0. So if I put 0 in for x, is it a true statement? So the nice thing about 0 is that anything times 0 is 0. So here we get 0 is less than or equal to 12. Is that a true statement? Yes, okay, so this point, it was a true statement. So that means I'm going to graph that side of the line. Here's a question. How many points are in our solution set? How many points are in the solution set for this problem? A lot. How many is a lot? Okay. Well, not all of them, but there's an infinite number of points that are in the solution because it's a whole region instead of just 1 or 2 points. Okay. All right, let's look at another one. Oh, here I have a graph, and we want to find this inequality. So that means we're going to do either y is less than or equal to mx plus b, or y is greater than or equal to, or it could just be less than or greater than. Okay. So let's think about it first of all. Okay. It's a dotted line, which means what? Okay, so it's going to be greater than or less than, right? Okay. Do you consider that above the line or below the line? Above, which means it's going to be greater than. So we're going to have y is greater than. Okay. Right? Its shading is above the line and it's dotted. So it'll be y is greater than. Okay. So now we need to find the equation of the line. What's the y-intercept in this case? 3. Okay, so we have plus 3. And then we need to find the slope. So we need to find another exact point that we can use to find the slope? Let's see. Right here? Does that look like an exact point there? Right there? Okay. Or there's one right here also at negative 1, 1. Okay. Oops. Can't erase that. There's nothing to erase. Okay, so. Here we go. There we go. Okay, so the slope is we're going to go up 2 and over 1, which means the slope is up 2 and over 1, which means that the slope would be 2 over 1. Okay. We went up 2 over 1. Y is 2, change in x is 1. Okay. So we would have y is greater than 2x plus 3. So now we're going to look at example 4, solving and graphing linear inequalities. And we have a little reminder here for you once again that if you divide by a negative, make sure you remember to change the direction of the inequality sign. So, first we need to solve this equation for y. And then we want to make sure that it's in slope-intercept form, so then we can graph it easily. So what's the first thing I should do to solve this for y? Because we've done problems like this where we've just solved the equations, and you've had a couple choices for what you do first. So what's the choice for what we're going to do first here? Okay, distributing is one of the things we could do. What's another thing we could do? Do what? Reverse the inequality? I'm not sure what you mean by that. Well, that's only if you divide by a negative. Okay, we're not dividing by a negative yet, so we will be, okay? Okay, or I could divide by 3/4. But if I'm dividing by a fraction, that means I'm going to multiply by the reciprocal, okay? So we can either distribute the 3/4 or multiply both sides by 4/3. All right, let's go in this case, let's go ahead and distribute the 3/4. So what's 3/4 times 8x? 6x? Okay, so 3 times 8 is 24, divided by 4 is 6x. Okay, that's correct. And then 3/4 times negative 2 would be what? Okay, or how about that as a fraction? Because we like fractions when we're doing this stuff. So negative 3 over 2y, okay, is greater than 6. Okay, so we're solving for y. What should I do now then? No, we're solving for y. That means we need to get everything else on the other side. Okay, so we're going to subtract 6x. And I'm going to write it as negative 6x plus 6 because I want to write it in slope-intercept form. Okay. And then how do I get rid of this negative 3/2 then? Okay. All right, we're going to multiply by the reciprocal. All right, so we're going to multiply both sides by negative 2/3. So we get y. And since we're multiplying or dividing by a negative, that means we're going to change the direction of the inequality. So negative 2/3 times negative 6 means we're going to have a positive 4x plus 4. Okay. So we'll go ahead and graph this. Let's move this over a little bit. All right, so we have a y-intercept of 4 and a slope of 4. Yes. Did I do something wrong?
How'd you get positive 4?
I have a negative times a negative. Oops, that should be negative 4, shouldn't it?
Yeah.
Thank you. All right. That should be a negative 4. That makes it much better. All right, get rid of that. Okay. So our y-intercept is at negative 4. And our slope is 4, which means we're going to do what? Okay, up 4 and over 1. And is this going to be a solid or dotted line? You see, it says just less than, so it's dotted. So we got a dotted line here. And so am I going to shade above it to the left or below it to the right? Is anybody anybody not sure? So let's check our favorite point, right? 0, 0. So I'm going to go back to the original. Okay. Going back to the original. Checking this point to see if it's true or not. Okay. So what's 8 times 0? 2 times 0? Okay. So we have 3/4 times 0. Is that greater than 6? So is 0 greater than 6? No, 0 is not greater than 6. So it's false there. That means I'm going to shade over here then. All right, so sometimes we have to do a little bit of work to get there, as in this case here.